Hi, hello friends. How are you doing? Hopefully good. Um, Reading group. Today we're going to be continuing with this paper. We started it last week. You don't have to watch the first part to join in now. What will it take to fix benchmarking in NLU? So make sure I got YouTube up. There we go. Good to go. So the paper is by Sam Bowman from New York University and George Dahl from Google Research. And it's sort of a position paper. So position papers are where the authors are like, this is what I think. This is like a problem in the field and like some ways that we could approach it. Or like, I think this is important. Is sort of the general genre of paper that this is. And hi Nick, specific thing, the specific problem that they're bringing up is that the way that we measure models that do natural language understanding right now is using benchmarks, right? So there's a specific data set and that has a specific train test split, and you train your models you train lots of different models with the same training data, and then you evaluate them with the same evaluation data. And the general problems with this particular model that they've identified is these ones. So good performance on the benchmark should imply Good performance on the benchmark should imply robust in-domain performance on the task. So the task is like something like, entity extraction or intent classification or other tasks in the NLU sort of genre of tasks. So if you do well on the benchmark, that should mean that this particular architecture and approach will work well on other instances of the same task, but with different data. And if you have, using our current benchmark structure, there's no indication that that is in fact the case. Benchmark examples should be accurately and unambiguously annotated. So we're going to start talking about that today in a little bit more detail. So basically the data that you're evaluating on should be right and it shouldn't be ambiguous. And I'm sure we'll talk about this in more detail when we get to it. Hi, Amina. Nick says, I have a couple of important questions. Can I ask? Yeah, if I think they're too off topic, I'll just sort of direct you to the forum. You know how I do. But yes, please feel free to ask. You shouldn't be trying to evaluate on wrong data, and also ambiguous data is very difficult from a machine learning standpoint, because if there are multiple correct answers for something, then if your task is to apply a single label, that is deeply difficult, right? Either you should be able to apply both labels or, something related, right? It's just harder from a machine learning standpoint. Benchmarks should offer adequate statistical power. And again, we'll talk about this more this section, but right now, a lot of the benchmarks systems are pretty much at ceiling, so they're doing about as good as it is possible to do on a specific task given a specific training data set. And that makes it really hard to pick apart differences between systems. And so additional statistical power means that you have more ability to tell the differences between groups, basically. And the way that you get more statistical power is usually more samples for whatever it is that you're sampling. In this case, particular language examples that are relevant for the particular task that you're doing. Hi, Ravi. Also, benchmarks should reveal plausibly harmful social biases in systems and should not incentivize the creation of biased systems. And we'll talk about that in more detail. So far, last week, we talked about sort of benchmarks generally, what benchmarks are out there, some of the problems, the fact that models that do well on benchmarks sometimes aren't even actually solving the task, right? They're picking up spurious statistical cues, and that seems to be particularly with transformers, a pretty strong trend. And, scientifically, in NLP, we want systems, like we want to be able to understand how to build systems that solve tasks robustly across domains, right? I want to be able to say like, oh, you're doing, a specific NLP task. Well, based on the available evidence, this particular approach is going to work well most of the time. And we're just kind of not there right now, right? Like we can say some things about models, but particularly deep learning models, it's not entirely clear what architecture changes will have what effect on the performance of the model in situ. And that's a problem in NLP, but also it's just like a larger machine learning problem that, you know, we're working on. It's sort of the thing that we're doing in the field. How can you get user location or IP address with whoever's interacting on the bot? So you're gonna have to do that from outside Rasa. It'll have to be some sort of thing that you do in, you know, in the website itself, or you can ask, which would be my preference from sort of a design and privacy standpoint, because then people can choose not to give you that information if for some reason they want to keep it private. And I would say IP address in particular is pretty sensitive information. So I would be very certain that it is necessary that you collect that. And also I would be clear to your users that you are collecting that. So yeah. All right, let's hop back into the paper. And we were talking about different ways to put together data sets, and reliable annotation is the section we're on now. For benchmarks to incentivize the development of sound new methods, sound meaning like reliable and good, the labels for their test examples should be reliably correct. This means avoiding 3 failure cases. 1, examples that are carelessly mislabeled. 2, examples that have no clear correct label due to unclear or underspecified task guidelines. And 3, examples that have no clear correct label under the relevant metric due to legitimate disagreements in interpretation among annotators. The first 2 cases straightforwardly comprise the validity of the benchmark, but the third is somewhat subtler. So basically, there shouldn't be like typos and like actual mistakes, and the annotation guidelines should have clear guidelines for everything that someone can run across. And sometimes also there might be like reasonable disagreements. Like in the third one is the situation where you could in fact have 2 labels. So intent classification, a good example of this would be like ciao or aloha. That could mean either hello or goodbye. So if like intent, you have an intent for greeting and an intent for farewell, that, you know, both of those things could legitimately be in both of those intents. Legitimate disagreement emerges when an example can be labeled in multiple ways depending on an annotator's choice between reasonable interpretations of an example in a text. Nope, of the text of an example. Such disagreements might stem from dialectal variants in the interpretation of words, or constructions, or different reasonable interpretations of the actual state of the world. So it could be, you know, some sort of language variation. So an example here would be if I see boot in a language data set, I'm going to assume it means a type of shoe, but someone from Britain might think it means part of a car, right? And both of those are reasonable interpretations of that particular word, but they depend on your dialect as a speaker. As a toy example, consider, did Ed ate a burrito entail Ed ate a sandwich? So if it is true that Ed ate a burrito, is it also necessarily true that Ed ate a sandwich? And the question here is a burrito a type of sandwich? And that, you know, you could argue yes or no there. While most US English speakers would likely answer no, many pedants and regulatory officials have argued for yes. So there might be like a legal definition of sandwich that does include burrito. Yeah, legal definitions of words are often different from the way that words are used in common usage. And what I have learned is that if you are going to be reading legal text, you should talk to a lawyer because they will know those things, and you probably will not, and it could be a bad time for you. When a benchmark contains many instances of this kind of legitimate disagreement, a machine learning model will be able to study the benchmark dataset's training set for clues about typical human behavior that might allow it to perform better than any single human annotator. This effect could contribute to misleading reports of superhuman performance on such benchmarks, where human performance reflects the benefits of humans who are reporting their own judgments, rather than attempting to predict the most frequently assigned label, as the model does. We observe evidence of this kind of ambiguity in existing benchmarks. For example, Pavlik and Kwiatkowski finds that 20% of examples across several textual entailment datasets are significantly, not sufficiently, significantly ambiguous. And Kwiatkowski et al. Show that 36% of short answer annotations in natural questions differ significantly from the majority answer. They don't talk about this here, but there's a sort of the idea of the wisdom of crowds. So if you have a large group of people and you ask them to say, estimate distance, right? Or estimate how many jelly beans are in a jar or something like that. Well, individual answers, it might be unlikely for people to get like this specific correct answer. If you look at the distribution of answers, usually the middle of the distribution will be very close to the true answer. And what they're saying here is that like when we talk about human performance, we are, looking at the distribution of answers. And when we talk about model performance, we are looking at the majority vote. So a more fair comparison, if you're really trying to compare to human behavior, would be to look at the distribution of the distribution of answers of the system, or take the majority vote of the humans, I think is what they're getting at here, that sort of difference in what we're actually evaluating. Question about storing it in conversation data in Postgres or SQL data column has values in JSON format, how to deal to fetch that only user queries such as text and confidence stores. Yeah, that'll depend on the specific structure of the data set. Yeah, I would probably ask that in the forums. Is this the forums? It's the forums! I want to spend some time making some more animations the next little bit, but probably not this month. I got a lot on my plate right now. Able to fetch the change by data type from the text and connect with Logstash, Elasticsearch, and display the results in Kibana. Yeah, I'd ask on the forums about that. I know about Elasticsearch, but I haven't used it extensively. I guess I've used stuff that rely on it, but I haven't like messed with it myself. All right, so this is talking about like, hey, the annotations data set, are they reliable? And also there was that paper that came out recently that found that like there were up to 10% annotation error rates in, I believe they were specifically looking at image data, but like major image data sets that benchmark the systems that are in products that you use if you use any computer vision products. And even if you don't use computer vision products, they're probably being used on you. Yeah. Amina says, when we read papers, is it for our knowledge and to stay up to date or to apply new techniques and aspects? Yeah, I would say it depends on the paper. So I try to pick papers that, based on the YouTube survey I did a while ago. So system papers where people describe a system they built and how it does, and like ablation studies and like, hey, this bit did this bit did this. That's definitely more applied. Papers like this, I think, are more for understanding. So survey papers and position papers, I would say, are more for understanding and knowledge and sort of building a clear understanding of what the field does and what its aims are and approaches. And then systems papers specifically are like, and here's how to do X. So, and I try to do a balance of it. The next paper will probably be a systems paper, although I do have a really good paper that I want to read. But I'm going to try and do a systems paper because I know that there's something that y'all find very valuable. There we go. Sorry, I just spilled tea on myself. All right. Statistical power. Benchmark evaluation datasets should be large and discriminative enough to detect any qualitatively relevant performance differences between two models. Basically, if you have a benchmark dataset, it should be hard and it should help you tell the differences between models. This criterion introduces a trade-off. If we can create benchmark datasets that are both reliable and highly difficult for the systems that we want to evaluate, then moderate dataset sizes will suffice. However, if our benchmark data sets contain many examples that are easy for current or near future systems, then we will need dramatically larger evaluation sets to reach adequate power. Okay, so this is talking a little bit about the fact that not all examples are equally easy, right? So when you are putting together a data set, your data set can be smaller if the examples are harder, but if the examples are easier, and easier specifically for the systems that are the types of systems that are going to be evaluated using the benchmark, then you need more examples. In the context of a reliable data set that is difficult for current systems, a 1% absolute accuracy improvement, such as that from 80% to 81%, may be an acceptable minimum detectable effect. In this case, an evaluation set of a few thousand examples would suffice under typical conditions seen in NLU. Many, though not all, popular benchmark data sets satisfy this size threshold. So this is, for system evaluation, you want, a couple thousand examples at least. For connecting the Rasa server with Rasa Action Server, you need a network connector for connecting the two containers and doctors. See you tomorrow. Thank you. Yeah, I think we'll be good tomorrow, hopefully. Greg helped me out. So I haven't actually tried the thing that he helped me out with, but we'll see if it works. I've got faith. He gave me like a nice little walkthrough. Since our systems continue to improve rapidly, though, we should expect to be spending more time in the long tail of our data difficulty distributions. If we build reliable datasets, much of their future value may lie in their ability to measure improvements in accuracy among highly accurate systems. For an example, an improvement from 98% accuracy to 98.1% accuracy represents the same 5% relative improvement as we saw from 80% to 81%. To reliably detect the smallest absolute improvement, though, requires 2 orders of magnitude more evaluation data. So if you look at sort of all of the things that they got wrong, if you get 5% more of them correct, if you got fewer right to begin with, that number is larger. If you got a lot right to begin with, that number is smaller. But if you want to say, hey, I only care about the difference when there is a 1% absolute difference in model performance, then you need a much bigger data set to see that. All right, so those are sort of the first 3 things. So we should have data sets that help us tell models apart. So I'm just grabbing a blanket, I'm a little cold. Data set that should help us tell models apart. We should have data sets that are correctly labeled and where the labels are a good reflection of human labeling. And we should also have data sets that are, what was the first one? Sufficiently hard, I think. Oh, right. We should have benchmark data sets such that good performance on the benchmark data set translates to other contexts. So they should be good sort of like measures of ecological validity. Ecological validity means that it works when you put it in the environment, basically. Which I think is more of a psychology term, actually. I don't think people in NLP really talk about that. All right. And finally, disincentives for biased models. A benchmark should, in general, favor a model without socially relevant biases over an otherwise equivalent model with such biases. Many current benchmarks fail this test. Because benchmarks are often built around naturally occurring or crowdsourced text, it is often the case that a system can improve its performance by adopting heuristics that reproduce potentially harmful biases. Developing adequate methods to minimize this effect will be challenging, both because of deep issues with both the precise specification of what constitutes harmful bias, which is going to be context dependent, and because of the limited set of tools that we have available to us. So this is socially relevant biases are going to be contextual for the specific society that you are going to be deploying the system into and who provided the data in the first place. And I've gotten, I don't know, this is something that in graduate school was one of my research areas, so I've thought about it quite a bit. And we also have some upcoming podcast discussions that I think will also be very, very relevant for this if this is something that you're thinking about in your work. And one thing So one argument about we shouldn't care about biases goes like, well, it just sort of naturally occurs in the text data, so it should be fine. But I think what that doesn't take into consideration, and we read the paper by Timnit Gebru and Emily Bender and Margaret Mitchell previously, the stochastic parrots paper, and they made this point as well. Naturally occurring data, when naturally occurring here means text data from the web, is not a good representation of naturally occurring language data, where naturally occurring means all language data produced by all people. So a great example for this, just from my personal experience, is of my friends who are on Twitter. I have a lot of friends on Twitter. My friends who are of very marginalized gender identities or sexualities are much more likely to take their Twitters private to avoid harassment. So even though they are producing language text, if I was building a scraper, I wouldn't see their language because of these outside societal forces that are, causing them to take steps to protect themselves. However, the people who are producing the harassing language don't have their Twitter set to private, right? They have it public, and if I were looking for, language data to scrape, I would get, in this case, language data from the harassers, but not language data produced by the people that they are harassing, because they chose to remove themselves from the public sphere to, again, avoid that harassment. And that is super, super, super common. So just because the language data is occurring naturally on the web doesn't mean that it's a good representation of, the actual language data in the world. And there's other forces at effect here, right? So government censorship is a really good one, a really good example of a way in which, yes, this is language data produced by people, on the web that you can find, but that doesn't necessarily mean that it's a good representation of language data more broadly, right? So just an example there of some ways in which I think there's this sort of desire to say, data are unbiased, and if we can find the language data, it's fine, and, people are actually saying this, so we should handle it, without considering, who's being excluded from these conversations. Ravi says, are you doing research on ethical AI? I wouldn't say that I'm actively doing research right now, but I am still involved in the research community. So I do a lot of too much. I need to stop saying yes to review requests, but I do reviews in the area, and it's something that we think a lot about at Rasa. Like how can we help people make ethical decisions in their work with conversational assistants? So anyway, just something that we're constantly thinking about, and I think it's really worth thinking about in general if you're working with language data. There is no precise enumeration of social biases that will be broadly satisfactory across applications and cultural context. Yeah, absolutely. So a good example of this is caste, right? So deeply important in India, less important in the US, although we do have a lot of folks from India here. So it is something that's, I think, part of the conversation in the United States, but it is not, I would say, as widespread of something that people think about. This can be most easily illustrated with a couple of biased associations between word representations in US English. Associations between race or gender and occupation are generally considered to be undesirable and potentially harmful in most contexts. For example, serving ads about job applications, which is something that Facebook has recently come under fire for, in that they are not serving job ads or recruitment ads to specific demographic categories of people, which is not good under the US legal system. And something that benchmarks for word representations should discourage or at least carefully avoid rewarding. If a set of word representations encodes typically Black female names like Keisha as being less similar to professional occupation terms like lawyer and doctor than typically white male names like Scott are, then a model using those representations is likely to reinforce harmful race or gender biases in any downstream content moderation system or predictive text system it gets used in. A great example of this would be resume filtering, right? So if you're using embedding on your resume text to produce some sort of predictive model, and your resume says like, oh, this name, that's not a lawyer name. This is going to be really far in the embedding space from the job title that they're applying for. That may, shift the system evaluation of that particular candidate. Adequately enumerating the social attributes for which we might want to evaluate bias in some context can be difficult. For example, Indian castes, like racial categories in the United States, are often signaled by names and are an axis on which managers sometimes discriminate and hire. Caste is a salient category of social bias in India that is subject to legal and institutional recognition. However, this bias also arises in some cases within the United States, where it has no such recognition, and where it could be easily overlooked by non-specialist bias researchers. Yeah, exactly. Fantastic example. And actually, there was, if you're familiar with some of the tech worker union movements in the United States, the one for Google, the Alphabet Workers Union, just released a statement on caste discrimination in the United States. It's very interesting if you want to take a look. Furthermore, building such lists of attributes is also deeply political. Within living memory, popular and legal attitudes have changed significantly in the United States about attributes like race, gender, gender expression, sexual orientation, and disability. Attitudes on these issues continue to change, and new categories can gain recognition and protection over time. In many cases, this means that choosing whether to include some attribute in a computational metric of bias means choosing which group of people to align oneself with on a political issue. While there are clear ethical rules of thumb to follow in doing so, making any particular choice is nonetheless likely to put researchers in conflict with established institutions in ways that can change quickly. Any strategy for handling bias in the context of NLP benchmarks will have to grapple with this difficult reality. Yeah. Absolutely. I think a good example of a tech company sort of interacting with a group and I would say political affiliation is not really group membership in the way that like gender or sexual orientation are, but there was a news story that broke a little bit about that Facebook had chosen to ignore some behavior by conservative news groups that they were punishing in other news groups in order not to seem as if they had an anti-conservative bias, and as a result had a pro-conservative bias. So again, political party is not the same as these other categories, but doing that had like that is a clear instance of a technological platform taking a political stance and aligning themselves with a specific political group, and that having an effect in the larger world. So every society has some problem. Yeah, no, I would definitely agree. Like, US has its problems, folk show. But I think it's, as researchers specifically, and also as technologists more broadly, we're building things that affect people in their lives, and it's important to consider, are we exacerbating existing systems that harm people, or are we working to mitigate those harms and to help move towards a more just and equitable world? And if that's not something you're thinking about, you're probably not moving towards the more just and equitable world, because you're probably reinforcing existing power structures. So it's just, something to think about, something to have in mind. All right, here's the problems. What are we going to do? Sketching a solution. Building new benchmarks that improve upon our 4 axes is likely to be quite difficult. Below, we attempt to sketch out some possible directions for improvement along each axis. Also, I know this looks like axes, like Lizzie Borden, a famous axe murderer, but it is axes. Building valid benchmarks will require significant new research into data collection methods, at least some of which should be specific to the task under study. Sounds expensive. Good, but expensive. We suspect that much of this work will involve improvements in crowdsourcing and the use of non-experts, as much of the annotation behind the tasks we discuss requires no expertise other than fluent knowledge of the language variety under study. One promising direction involves methods that start from relatively high-quality crowdsourced data sets, then use expert effort to augment them in ways that mitigate annotation artifacts. Sorry, let me run that through my brain one more time. Okay, so you start with good crowdsourced data, and then you use experts to continue to improve the data sets. The build it, break it challenge. Oh, I remember that the open reading benchmark and the Gardner et al. Contrast sets, among their other features, allow expert annotators to add examples to a test set to fill perceived gaps in coverage or correct perceived artifacts in a starting set of crowdsourced examples. And I will say, the first author on this paper, Sam Bowman, just had a paper out. I think it was a preprint. I don't think it was published anywhere, but it might have been. Sort of testing out one of these applications. So having expert linguist annotators go through and do some work after. And what they found was that the things that they asked the linguists to annotate for did get fixed, but the sort of by some other measures of overall data set quality, the data didn't change much because those measures of data quality included some things that the experts weren't asked to annotate for. So I would say, just based on that work, my little sprinkle of wisdom on this would be annotation guidelines are so important. So important. You get what you ask for, right? Especially in an experimental context. To the extent that crowdsourcing with non-experts can produce data that has broad coverage and high difficulty, but retains some measurable artifacts or flaws, this compromise approach may help to create a usable benchmark data set out of the results. And this talks about the ACM, the Association for Computing Machinery Code of Ethics. It states, when the interests of multiple groups conflict, the needs of those less advantaged should be given increased attention and priority. And I believe that the ACL publicly, so the conference at which this is being published, the professional organization that is running that adopted the ACM Code of Ethics as well. Or endorsed it, something like that. And if you haven't read it, I'd recommend it. I think, every technologist should have, both adhere to a general profession-wide code of ethics and also have their own code of ethics that may go beyond that. Another approach brings computational linguists directly into the crowdsourcing process. This was recently demonstrated on a small scale by Hu et al. With OCNLI. It's probably just OCNLI. They show that it is possible to significantly improve data quality issues by making small interventions during the crowdsourcing process, like offering additional bonus payments for examples that avoid overused words and constructions, without significantly limiting annotators' freedom to independently construct creative examples. Oh, I like that. So if you're getting like a specific bag of tokens as being overused, and you're like, hey, I'll pay you more if you don't use these tokens. Yeah, it's kind of fun. There's a game like that. I don't know how popular it is in other places, but it's called Taboo. And basically you have a card, and at the top is the word you're trying to get your partner to guess, and underneath it are words that you can't say. So like if it was mouse, they'd be like, don't say animal, or eek, or squeak, or cheese, or ears, or tail, or something like that. And then you're trying to get the person to guess the word. So you tend to use less frequent words in your description. So it looks like they're using that as sort of that general elicitation paradigm as a way to get more diverse language data. Diverse at the token level. Of course, implementing interventions like these in a way that offers convincing evidence of validity will be difficult. Yeah, because you're getting more diversity, but you're getting more diversity through artificial interventions. Improving handling of annotation errors and disagreements. The use of standard techniques from crowdsourcing, generally involving multiple redundant annotations for each example, can largely resolve the issue of mistaken annotations. Careful planning and pilot work before data collection can largely resolve the issue of ambiguous annotation guidelines. Yeah, I just want to emphasize how hard that is. It is very difficult to write clear annotation guidelines. And I think that this is also important for people who are working on Rasa assistance. So for entity and intent and annotation, making sure that everybody on your team who's doing the annotation knows like what this intent is can be very difficult. And it's important to have clear annotation guidelines. And I would say it's a little bit easier with a team of annotators that are working on an assistant because you can talk to each other probably, like you can have a meeting together. But if you have, 10,000 crowd workers, you're not going to get them in a room and be like, all right, let's all agree. This is example A and it's, category 1 or whatever. Handling legitimate annotator disagreements can take two fairly different approaches depending on the goals of the benchmark. So I mentioned here the difference between looking at the majority vote from the system and individual inputs from the annotators and seeing the distribution. Here, instead, we're looking at the majority vote from the annotators and the majority vote from the system, so it's a fair comparison. And I think their hypothesis would be if you take that approach, you are less likely to see superhuman performance because you are seeing the performance of a group of humans, not a single human. Also, a group of humans that are incentivized to work as quickly as possible, which is not usually the conditions under which you get the lowest error rate. The simplest approach treats ambiguously labeled examples in the same way as mislabeled examples and systematically identifies and discards them during a validation phase. For some tasks, it may still be possible to test a model's handling of fundamentally ambiguous linguistic phenomena or domains using unambiguous examples. In the case of multiple choice question answering, for example, one can construct examples where one answer candidate is only debatably correct, but all the other candidates are unequivocally wrong. Any sound model will then be expected to select the debatable choice. So basically they're saying, hey, you can handle ambiguity by getting rid of ambiguity, right? Or making, when there are potential ambiguous things, only having one ambiguous thing at a time. But like the problem with that is that there is ambiguity in natural language use, and humans are really good at resolving it. And my assumption would be that a system that has high performance, usually people are looking for human-like performance in language systems because language is a human system, would expect those systems to behave in a human-like way and be able to resolve ambiguity on context. Alternatively, one can decline to assign single discrete labels to an you don't have to give every ambiguous item a label. This can involve asking models to predict the empirical distribution of labels that trustworthy annotators assign, or allowing models to predict any of several answer choices that are supported by trustworthy annotators, as in the squad benchmark. This comes at a cost, though, of requiring many more annotator judgments per evaluation example. So this one is instead of converting the annotator examples to majority vote, you create the system. You create the system output should be a distribution, which could be. I feel like that could be useful. I feel like it would also be more data hungry and potentially also more computationally expensive. Robbie says, my English isn't conversational. I partially understand. We should have closed captioning up. Yeah, it may only come up after the video has been uploaded. But these, if you're watching in the future and you're missing parts of what I'm saying just from the speech signal, try turning on the closed captioning. It is pretty good from me because I'm an upper class white lady using I'm an upper middle class white lady using my professional voice, so I am pretty legible. Also, I've got a pretty good mic, and it's right next to my face, and moving that destroyed my mic stand. It's I am physically holding my mic up right now, so that's a thing that's happening. I guess I'm just gonna hold it up for the rest of the thing, and we'll handle it that way. And apologies. I cannot hold this for 20 minutes. All right, hold please. Well, it's slowly drooping, but I don't have to physically hold it up. Hold, please, again. All right. With that exciting interruption out of the way, uh, the closed captions are pretty good. Oh, all right. Moving on to we finished this section here, I believe. Improving statistical power. uh, thank you, Amina. Thanks y'all for being understanding. Technical difficulties. Improving statistical power. In principle, achieving adequate statistical power is straightforward. We simply estimate the number of examples required to reach the desired statistical power for any plausible short to medium term system evaluation for the text and collect that number of examples. In practice, however, costs can become prohibitive. So basically, if you know how large the effect size is likely to be, which we generally do in NLP tasks, a lot of these people have been working on for a long time. We have a lot of samples, we have a lot of data sets. You can know, okay, if I want to be able to tell like systems with this degree of difference apart, this is the number of samples that I need, and you can calculate that ahead of time. So if you're doing psychological experiments and you're like, how many people do I need for this experiment to be able to actually see the effect that I think exists, you can estimate that. But collecting data is expensive, annotating a data is expensive, storing data is expensive, and it all costs money. Well, yeah, I also know that I'm a very fast talker, Ravi. So even for an English speaker, sometimes I can be a little much. For a relatively simple task like NLI, natural language inference, labeling an existing example likely requires a bare minimum of 45 seconds, and creating a new example requires at least a minute. Even if we use these very optimistic numbers to estimate annotation speed, a 10-way annotated dataset of 500,000 examples will still cost over $1 million at a $15 an hour pay rate. This figure ignores platform fees and makes the additional optimistic assumption that only 10% of fully annotated examples will be discarded because of annotator disagreement. And I believe, so Sam Bowman is in New York City, and I know there was just something with minimum wage in New York City. I don't remember what it is anymore. But particularly for like expert annotators, that is not. I would say that's a little bit on the low end. Recruiting more experienced annotators or encouraging annotators to work more carefully could increase that figure dramatically. While such an amount of money is not completely out of reach in a well-funded field like NLP, investments of this kind will inevitably be rare enough that they help reinforce the field's concentration of data and efforts on a few high-resource languages and tasks. Yeah, so like, sure, Stanford probably has $1 million to spend on an NLP data set, right? Squad is a Stanford data set. I'm pretty sure the S stands for Stanford in that. But, is a university in Nairobi going to have $1 million to create a data set for NLP? Like, maybe they do, but maybe they don't, right? And if it's English speakers that have the money and they care about English, then it's only English that's going to get studied. And that sucks, right? That's not fair. That's not good for the long-term well-being of humanity. And yeah, it's a problem. Not to mention the tasks that are going to be focused on are going to be the ones that have strong commercial applications because companies are going to pay for them, and things that are maybe very important to individual people, but they don't have the millions of dollars lying around to fund creation of data sets for, just aren't going to get studied. For settings in which large data sets are necessary, we see no clear way to avoid high costs. Gamification, in the style of an ESP game or zombie lingo, promises to offer free human labor, but at the cost of the expert time needed to refine the task definition into a game that's widely enjoyable. Excuse me. Probably the most well-known gamification of scientific data annotation example is Galaxy Zoo, which is where you go through and you click on galaxies and you're like, this galaxy is this shape, this galaxy is this shape. And there's also a I'm blanking on the name. Oh, what's it called? Well, I don't remember the name right now, but there's also a site that does like gamification of scientific data analysis for a variety of fields. Like I have a friend in acoustics who did it to help identify the sort of acoustic centers of Indian steel pan drums, like West Indies, using sonogram data. I don't remember what he was using, but anyway, like you'd click on the picture to help do the data annotation. That was a weird aside that I don't think added much to the conversation. This approach also introduces severe constraints on the kind of data collection protocols that can be used and raises tricky new ethical issues. Ultimately, the community needs to compare the cost of making serious investments in better benchmarks to the costs of wasting researcher time and computational resources due to our inability to measure progress. And I will say, like, it is expensive to create a data set, right? So this hypothetical example is $1 million. I think it cost something like $12 million to train GPT-3, right? So it is not that there is not money in the field. It is that that money is not... Creating data sets and benchmarks doesn't seem to be the long-term goal of a lot of the very well-funded research groups. Which... that's what it is. That's the exact point that's in this footnote. To put this number in context, public estimates of the cost of OpenAI GPT-3 exceed 10 million, and in machine translation, Meng et al.'s use of 512 NVIDIA V100 GPUs for 3 months would have cost over $1 million on commodity cloud infrastructure, right? So, like, it's clear that the money in the field exists. It is also clear that dataset creation is not being pursued to the same degree that training ever bigger models is. Because there is no one-size-fits-all definition of harmful social bias, there is little prospect of creating a benchmark for language understanding that is guaranteed to never reward the development of harmfully biased models. This is not a compelling reason to accept the status quo, and we nonetheless have a clear opportunity to mitigate some of the potential harms caused by applied NLP systems before these systems even get deployed. Opting not to test models for some plausible and potentially harmful social biases is, intentionally or not, a political choice. So like I mentioned, if it's not something you're thinking about, you're probably aligning yourself with whatever the most powerful group is in the society that you're working in. While it would be appealing to try to guarantee that our evaluation data does not itself demonstrate evidence of bias, we are aware of no robust strategy for reliably accomplishing this, and work on the closely related problem of model bias mitigation has been fraught with false starts and overly optimistic claims. Yeah, it's hard, right? And actually Vincent has a good series of videos. I think we also read that paper together, the lipstick on a pig paper. Like, debiasing word embeddings does not guarantee a debiased model, right? So what you measure for and what you care about and where in the development of the model process you do that measuring and caring, has very different effects on the outcome of the model. A viable alternative approach could involve the expanded use of auxiliary metrics. Rather than trying to fully mitigate bias within a single general dataset and metric for some task, benchmark creators can introduce a family of additional expert-constructed test datasets and metrics that each isolate and measure a specific type of bias. Anytime a model is evaluated on the primary task test set in this setting, it would be evaluated in parallel on these additional bias test sets. This would not prevent the primary metric from unintentionally and subtly rewarding biased models, but it would combat this effect by more directly highlighting and penalizing bias in models. In addition, the fact that these metrics would target specific types of biases would make it easier for benchmark maintainers to adapt as changing norms or changing downstream applications demand coverage of additional potential harms. I really want to move this closer because I know it's a little bit quiet, but I feel like I'm just not willing to try and fix nothing again. For several tasks, metrics like this already exist, at least for gender and English, in the form of auxiliary test sets meant to be combined with pre-existing training set. I think the Webster paper is lipstick on a pig, but I'm not entirely sure. Even so, refining these metrics and developing new ones will likely require us to face many of the same challenges that we highlight in this paper for benchmark design more generally. Expensive, how you tell annotators what you care about. It takes a lot of time and effort to make sure that your annotation guidelines are good. What social categories do you care about, right? So at least for me in NLP, I think gender is for American English specifically, I think gender is less important than being able to fluently handle regional differences, and sometimes they're called ethnolex, so things like Chicana English Chicano English and African American English, and all of the various varieties of English that have more systematic differences between them than language used by speakers of the same variety but different genders, right? Personally, I don't think gender is important as other factors like socioeconomic status and race. The larger challenge in implementing this approach, however, is a matter of community structure and incentive design. Methods paper dealing with tasks for which metrics already exist rarely report numbers on these metrics. Even for the superglue benchmark, which requires users to compute test set metrics on the DNC Wino gender test set in order to reveal test set results for any other target test set, a large majority of papers that report test set numbers omit this metric and decline to report potentially unflattering bias numbers. That's a spicy paragraph. So just for reference, Sam Bowman is one of the authors on the superglue dataset. And what he's saying here is like, hey, we are requiring you to do a bias test and you are choosing not to report the numbers for that. And I know you have those numbers and I've seen that you've done it and I'm citing you so that you can see the citation notification and come read the paper and be like, oh, Good point though. Yeah, like why aren't you reporting those numbers? Is it because they're bad? I feel like people who are interested in using your systems and learning more about your systems should know that, right? Yeah. Which metrics are used mostly to measure NLP accuracy? It depends on the task. So I know that's like a very that's an unsatisfying answer, but yeah, it's the truth. It just depends on the task. The difficulty then is in developing community infrastructure to encourage the widespread reporting of metrics that address the full range of relevant likely harms. This could plausibly involve peer review norms, explicit publication venue policies, stricter versions of the superglue approach for which numbers can only retrieve aggregate performance numbers, users can only retrieve aggregate performance numbers without a precise separation of the primary and bias-oriented metrics, or even the introduction of professional licensing standards. And I will say at least one of these has occurred. So as of this ACL, I think the next one coming up, you are required to include an ethics statement with your paper talking about sort of the ethical ramifications of your work. Like, did you pay your consultants? Did you think about harms of the bias, etc.? And yeah, so this paper, in fact, also has an ethical consideration section. And as part of the review process, there was also a separate ethical review process with reviewers trained in ethics who went through and provided additional feedback on the papers. Yeah, Robbie says, in Hindi, gender is more important. Yes, so in languages that have more gender markers, I can definitely see that would be more important. In English, we kind of don't. We have pronouns, but that are gendered, but it's rare for you to talk about yourself as pronouns. And like there are differences between even in English, sort of the way that historically, at least, studies have focused specifically on men and women, but there's a growing body of work on people of other genders as well. And there are differences in language use. Deborah Tannen did a lot of the early work on sort of like, I think she has a book called like How Women Speak or something like that. So there are differences, but they are not as robust as the differences between, say, you know, me and another woman who is a speaker of African American English. We're going to have more differences in our language use than me and, you know, a white man who speaks my same language variety, right? That's the point I'm trying to make there. Of course, ensuring that bias is measured and reported is not enough to prevent bias-related harms from emerging in practice. It is also necessary to ensure that those who build and deploy NLP products will take these metrics seriously and respond to them appropriately. That's us. And of course, even if a system encodes no social biases at all, I don't know that that's possible, it can still be deployed in ways that produce unfair or unjust outcomes. These difficult issues are beyond the scope of a paper on benchmark design. That's fair. And honestly, this is more the one that keeps me up at night, is people building NLP systems to like cause or exacerbate existing harms. Right. Related work. We're almost there. The NLP and ML research communities are increasingly interested in issues surrounding data and evaluation. This section surveys relevant positions and issues that don't quite fit our schema. Whatley et al. Advocate for more precise reporting of the focus and ability of test sets in metrics in machine learning broadly, with a focus on issues surrounding statistical powers. Bender and Friedman, that's Batya Friedman. She's done a lot of stuff with participatory design. And she talks a lot about sort of considering stakeholders in system design. Anyway, she's got really interesting work, and I'd recommend it if you're interested in design and ethics. And Gabru et al. Advocate for explicit freestanding data sheets documenting dataset releases of all kinds, with their focus on making potential harmful mismatches between data and application visible. And Hutchinson et al. Argue along similar lines for a broader program of transparency and stakeholder engagement in data creation. Stakeholders are basically everyone who is affected by the system, not necessarily just the people who are paying for the system to be built. Dodge et al. Lay out a set of best practices for results reporting with a focus on impact of hyperparameter tuning on model comparison. Ethayaria? I don't know what the J is, or honestly some of these vowels either. I apologize if I'm saying that incorrectly. And Girafsky advocate for the inclusion of efficiency considerations in leaderboard design. Boardgraber and Borschinger? I don't know what the amounts on the mean. Describe ways that trivia competitions can provide a model for carefully considered dataset design. Church and Hessness revisit the argument that motivated the NLP community shift towards quantitative benchmarking in the early 1990s, and warn that the overwhelming success of this shift has indirectly laid the groundwork for the widespread use of poor quality benchmarks. Ooh, I might read that. That sounds interesting. I really enjoy papers that put a scientific community's work and best practices, current best practices, in context, particularly a historical context, because it really helps you understand like why people do things the way they do it. And also they tend to pick apart sort of like assumptions that people make. Like, of course you do X, we've always done X. Well, probably not always. Probably not always. There was probably a point at which someone decided to do X and the rest of the community got on board. And like, what was that process like? Blodgett et al. Challenge researchers working on social biases in NLP to focus more precisely on specific types of harm to specific populations of users, a challenge that our broad position piece does not fully meet. This is Sue Lynn Blodgett. She's fantastic. She's at Microsoft Research right now. And keep an eye on our podcast, maybe unrelated. I'm really excited. NLP has had long-standing debates over the types of tasks that best test substantial language understanding skills. Many task-specific papers contribute to this debate, as does a prominent recent thread advocating for an increased focus on grounding in various kinds by Bender and Kohler. Reread this. This is the paper with the octopuses. Bisk et al. And Zellers et al. And others. Conclusion. Benchmarking for NLU is broken. We lay out 4 major criteria that benchmarks should fulfill to offer faithful, useful, and responsible measures of language ability. We argue that departing from IID evaluation, independently and identically distributed, I remember the I this time, as seen with benchmark data sets collected by adversarial filtering, does not help to address these criteria, but lay out in broad strokes how each criterion might be addressed directly. Nonetheless, important open research questions remain. Most centrally, it is still unclear how best to integrate expert effort into crowdsourced data collection, and we do not yet see clear institutional model by which to ensure that bias metrics are built and used when they are most needed. He's so upset that people are getting around the bias metrics in Superglue. That is me reading into somebody's emotional state, by the way. They've written a passage in an NLP paper and nothing else. Ethical considerations. This paper advocates for reforms to a set of benchmarking practices that have so far largely failed to address issues of social bias, and that have thereby helped create a false sense of security among those building applied systems. While this paper offers no complete and satisfactory solutions, it proposes measures that should contribute to harm reduction. I think it's a pretty good ethical statement. Amina says, I can see what you mean, but I think the upbringing of each of us impacts how we talk and express ourselves, and even education. Yes, absolutely. So I mentioned very briefly socioeconomic status. And this is, I'll get a little bit more into the sociolinguistics, which is, again, hi, Madrana. Welcome to the stream. So education in particular is very important in the United States because it is deeply tied to socioeconomic status and like self-reported class. The interesting thing about social class in the US is that everyone will tell you that they are middle class, right? Nobody's going to say I'm working class. It's very rare for someone to say that they're working class, and no one's going to say that they're upper class. And also, the US doesn't have like an aristocracy in the way that a lot of European countries do, but there's still sort of like a space in our conception of hierarchy for like the ghost of an aristocracy. Anyway, I don't want to get into it too deeply. But what I wanted to say is that a lot of people have started talking about a professional class. So these are people who are college educated, move around a lot, work white collar jobs, and are well paid. So I would be in this framework. I would be in a professional class, and the going to college experience and preparing for a career that is like a white collar career, even if you don't get that career, which, I mean, I'm a millennial. A lot of my peers went to college and got jobs that they did not need college degrees for, but they still went through this social enculturation process, right? And as a result, they have the sort of the professional class voice. And that process really sort of irons out a lot of regional differences. It irons out sort of a lot of the variation in language and creates its own language variety that is seen as being unaccented, that is seen as being neutral. And the difference between those speakers and other speakers that have an identity that's more, that maybe would call themselves working class, even if like financially they're, you know, above people who would consider themselves professionally class, is a really interesting dynamic. And the people who don't have that sort of professional class, unaccented, everybody has an accent voice, tend to have more variation. And that's, you know, that group of people in particular, I think that speech-based systems don't serve very well. Anyway, just like a big expounding, but yes, you're absolutely right. Class in the US is weird, but I definitely agree. Education level in particular has a large component there. In the US, education is free. They get sent to government school. You can choose to pay for it. So there are schools where you pay to send your children there, and it is free through the 12th grade. But what I'm talking about is going to college, and that is paid for. Although there's 4-year colleges and then what are called community colleges, which are 2-year colleges, and they give you another degree. Usually they're not residential. Often they're sort of combined with trade schools. So they're seen as, I love community colleges. I went to a community college. Nothing but good things to say about community college. But the social perception is that they are like below these 4-year colleges where you'd get a bachelor's instead of an associate's degree. And there is a discussion of making community college free, but 4-year programs are ungodly expensive. Like really expensive. My generation is in what I would say crushing debt because of, so the professional class of my generation, I would say, is in crushing debt because of this. It's, yeah, it is common for people to take on more money than a mortgage would cost to acquire a 4-year degree. Anyway, oh, also, it's the only type of debt that can't be forgiven. Like, if you declare bankruptcy, you can get out of other kinds of debt. You cannot get out of student debt. It follows you to the goddamn grave. Anyway, I think that's enough to talk about the sort of American social structure right now. Yeah, so broader points, lots of thank yous to various folks, and then funding as well. Yeah, really interesting papers. I think that the authors bring up a lot of problems and are like, fixing these problems is going to be expensive and we're going to have to convince people that it's important. I would say the implications for somebody working on a Rasa assistant are not that dire, right? Because we don't use benchmarking. That's not the conversation-driven development way. We use expert annotations of data in situ, like the data that people are actually using. And because you have that data, if you wanted to compare multiple systems, you could do that, again, with the actual data that is an actual representation and sample of the particular instance of the task that you're doing it for. So I don't think it's as important for us to think about benchmarks. What I think is important for us to know is when, someone talks about like, oh, this hot new algorithm has, top of the leaderboard for, XYZ benchmark, keeping this in mind, because it may not be, a good fit for the specific type of task that we are talking about. So a really good example of that would be, we read a paper a while ago about Vietnamese, I'm pretty sure. That face was me trying to remember if it was Thai. I was just talking about a Thai system, but I'm pretty sure this one was Vietnamese. And they used both the fast text embeddings for Vietnamese and also the multilingual BERT embeddings for Vietnamese. And if you looked at the benchmarks, you'd say like, well, of course, the multilingual BERT ones are going to be better. They're at the top of the benchmarks. But for the amount of training data that they had, their system did much better with the fast text embeddings than the multilingual BERT embeddings. So in that case, going by the benchmarks rather than evaluating on your own specific data that you're using for your project would have given you a wrong result, right? You would have been able to get better performance from your system using a different approach that wasn't so good on the benchmarks. So yeah, I think my biggest takeaway for the Rasa community is benchmarks can be helpful, but they are not without their flaws, and I wouldn't trust benchmark results unconditionally. Anyway, thank you so much for joining today. I hope you had a great time. I hope y'all are staying healthy, doing the best that you can. And I will be back tomorrow for live coding, and we'll fix our Docker compose install. And thank you so much, everybody who's reached out to me with help. I appreciate it. It's been a really good learning experience for me. I'm understanding Docker better, but I'm still at the point of the learning journey where you get like frustrated frequently. So we'll get past it. All right, so I'll see you tomorrow for that. Yeah, and have a great day, and I'll talk to you then. Bye.